So I'm just doing a revision lesson on vectors. So much of this is GCSE, but the addition of three-dimensional vectors and some difficult geometry problems are the sort of additional A-level pure sections here. So I'll just start off with some key bits. The first sections are things where you've got vectors with numbers in. You might have to deal with things like magnitudes, parallel vectors, things that are collinear, and then we'll get on to the more difficult geometrical problems where you have to approach a point from two different ways to find the ratio. So we'll start off with question 1. Find AB vectors. This is the most important skill. When you're finding AB, you do end position vector minus start position vector. So AB is B minus A. And we get, so this is the position vector, sorry, this is the journey vector to get from A to B. Let's just say something else quickly. This is the position vector of B. That's the journey to get to B from the origin. This is the coordinate of B. A coordinate is just a point. So minus 1, 4 is about here. So this is where B is. So the coordinates, written horizontally like this, mean that particular point. Minus 1, 4 is the vector, is the journey that would take you from the origin to that point. So A to B is minus 1, 3. That's part A done. Find the magnitude of BC. So to find BC, I do C minus B, which is going to give me 11, 1. And I want to find the magnitude of it. I can write that like this. You should know that notation. Sometimes you'll see it with double vertical lines like this. And that would be the square root of 11 squared plus 1 squared. And then you might need to simplify if necessary. Find D if CD equals two lots of AB. So here's some point D. I'm trying to find where it is. I'm trying to find its coordinates. So what I'm going to do is I'm going to try and find O to D. I'm going to try and find this position vector, then that'll tell me where the coordinates of D are. But I don't know much about D, so I'm going to go via a different point which I do know about. So let's say C is here. I'm going to go via C, and then I'm going to go C to D. And the reason why that's good is because I know where C is, and I know something about C to D. So O to D, the thing I'm trying to find, is O to C plus C to D. O to C we know is 10, 5, and C to D, we know that's two lots of A to B, which we've already worked out earlier on. So we get 10 plus minus 6, and 5 plus 2. So that's O to D, but it did ask me where D was, so I guess I should give it as a coordinate. It might say find the coordinates of D, or it might say find the position vector of D, and you need to pick the right one as your answer. Part D, parallelogram. Here's A, here's B, here's C, let's say. And now E, where could it be to form a parallelogram? Well, it could be here. So we've got C to E here is parallel to B to E, B to A, mine doesn't look that good, and B to C should be parallel to A to E, something like that. Some people might be thinking, well, could it be up here? And then you can make a parallelogram A, B, E, C like this, but the order is important. So when it says A, B, C, E, that means as you go around the shape, it comes in that order. And there's no way of going around this shape, this parallelogram, the purple parallelogram, which would end up with B and C next to each other. So that's not really a possible option, unless it said a parallelogram is made of 4 points, A, B, C, and E. Anyway, so in this case, it must be that back parallelogram there. And I want to find out where E is. So I want to know OE. Now, I don't know much about E, but I do know about some other things. I could go via C, for example. So I could say O to C plus C to E, and that's good because I know about C to E. So O to C we know is 10, 5, and C to E we know from looking at our diagram is parallel and the same length as A to B because it's a parallelogram. Sorry, so it should be BA, not A to B, in fact, in this case, because of the direction. So that's going to be 10, 5 plus the negative of A to B, so 3 minus 1, so we get 13, 4. That's a position vector of E, so if I want the point, if I want the coordinates, then 13, 4. And then finally, let's find the angle for ABC. Now, it's not that common that you need to find the magnitudes and use trigonometry, but in this sort of question, that is a good way to do it. There is another way, but it's not on the single maths course. There are, in fact, a couple of different ways, or a few different ways, but this is probably the easiest way for a single maths approach, and find the magnitude of each one. So this one is root 10, this one we've already worked out is root 122, and this one we can work out, and you get root 68. And then we can use the cosine rule, so call this angle here theta. We can say cos theta equals b squared plus c squared minus a squared over 2bc. Use those magnitudes, and you get an angle of 23.63, I believe. Okay, so that's some sort of basic key skills with number-based vectors in 2 dimensions. Now, all those same principles apply for 3-dimensional questions as well. There really isn't any extra things to learn. You'll notice that most of my diagrams in the first question, I didn't draw an x and y axis anyway. I just drew random points just so I could see how the points interacted with each other, and that's going to be the same thing here. So if I want to draw a diagram, it doesn't matter, it's 3 dimensions. I'm going to draw A, B, and then supposedly they're all collinear. So A, B, C are all in a line. And if things are collinear, what that means is they pass through the same point, but they're also going in the same direction. So I'm going to say the fact they're collinear means that AB is parallel to either AC or BC. Doesn't matter which one you pick. So in this case, I'm going to say AB is equal to B minus A, and I get minus 5, minus 1, minus 1. And BC equals, this one's going to have some algebra in it, C minus B, of course. So that's P plus 1, 8, and Q. If they're parallel, it means they're multiples of each other. So P plus 1, 8, Q must be a multiple of the other vector. We could just use 5, 1, 1, but I'm going to use minus 5, minus 1, minus 1, in case it confuses anyone. And I'm going to turn that into 3 equations. P plus 1 equals minus 5k, 8 equals minus k, and Q equals minus k. And might have to solve simultaneously or something like that, but in this situation, as often will be the case, there is actually just a way of doing it such as this. So k is minus 8, which means that q is 8, and this makes p plus 1 equal to 40, so p must be 39. And there we have our answers. Now, if the question gives you information in this format, I recommend that you just turn it into column vector form. There is absolutely no need at all to work in IJK form. I think it's easier to see what's going on in column vector form, and I imagine most markers think it's easier to see what's going on. Most people work in column vector form. It might be the case that you then need to convert it back to the other form just to give your answer, but that's a simple step. The only reason the IJK form really exists is because it's easier to write. Well, on a typewriter or in a textbook, it takes up less space. Show that AB and CD are parallel, and the ratio. So here we're just going to find AB, and it doesn't matter if it's 3-dimensional vectors, it's exactly the same principle. In this case we get AB is this, and CD and we can say that CD equals negative 2 times AB, AB. Therefore, CD is parallel to AB, and the ratio, well, in this case, I suppose it's 1 to minus 2. Probably more likely you'd be asked for the magnitude ratio of the magnitudes, in which case it would just be 1 to 2. Oh, sorry, I should say 2 to 1 based on the way it's written. Let's change that. So if it was asked for the magnitudes ratio of the magnitudes, it would be 2 to 1, but in this case, I'll say minus 2 to 1. Hence describe the quadrilateral. So you've got AB, then you've got CD, but remember the CD is longer than A to B. So you've got C to D. I haven't left myself enough space really. In fact, I've just put the D in the wrong place, haven't I? Because it's supposed to be minus 2 lots of A to B, so it should be down here. So there's my D. So I've got this one here, and it's parallel to this one here. So but this one was double the length, but they are parallel. So a quadrilateral where you have one pair of opposite parallel sides, but the other sides aren't parallel, is a trapezium. Okay, then we're on to the geometrical problems. So in this case, we can say that AB is the vector I, and and CD is the vector j. Find an expression for BC in terms of I and j. So I want to get from B to C, but using the horizontal and vertical direction. So the thing to do here is to consider a central point. Or the other option is take an additional point just outside, so go along and form basically a right angled triangle. But the thing is that this line here, let's call this x for a moment, b to x is not equal to I, it's equal to a multiple of I, let's call it ki for a second. And what is it? Well, we know that this length here, let's say this has a length of 1. And we've got an isosceles triangle, so using Pythagoras you can work out the lengths of these two things. And if this one is a length of 1, then this should be 1 over root 2 or root 2 over 2. And this one should be root 2 over 2. So in the end we find that BC equals root 2 over 2I plus root 2 over 2j. Underline our vectors. Okay, moving on. Okay, x is a point on AB such that it splits it in a ratio of 1 to 2. So it's a third of the way along. So 1 to 2. Prove that CX equals 2/5 of CY. So to get from C to X, I need to go via somewhere else. So I could go via A, or I could go via B. Let's go via A. So C to X equals C to A plus a third of A to B. C to A we know to be 3A, and a third of A to B. Now A to B would be going back here to C and then up to B, so that will be minus 3A plus 6B. So that gives me in total 2A and 2B. That's C to X, and then C to Y, let's get there going via B, because we seem to know information about B to Y, so C to B plus B to Y, C to B is 6B, and B to Y is 5A minus B, which gives me 5A plus 5B. So you can see that C to Y equals, let's call it 2/5, let's call it 5 over 2 lots of 2A plus 2B, or in other words, 5 over 2 lots of CX. And then I should have maybe done it the other way around, so I'll just flip it now, 2/5 C to Y. That sort of type isn't too difficult. There's no need to bring in an extra variable, extra parameter there. So now we move on to the slightly more difficult questions. Okay, so in this case, we're trying to find out where P is. We're not told. We're told information about other locations. So we know that M is the midpoint of O to A. So let's label some vectors. So O to A is A, and the other one I believe is going to be called, it's going to be called C. This one's going to be called C along here. So that's all the way from here to here. And this one's all the way from here to here. We know some ratios. We know this is 1 to 1. We know this one is 1 to 3. But we don't know where P is, we're going to have to find it. And the way to do that is to use the two different diagonals, which use the two different bits of information. So at some point we're going to want to know MQ. So let's do that now. So M to Q, I can get there by going M to A plus A to B plus B to Q. So M to A is half A plus C plus B to Q is a quarter of B to C, which is minus A. So I'm going to get a quarter A plus C. So that's M to Q. So if that's M to Q, then P is somewhere along that, but we don't know where. So let's say that M to P is lambda, a new variable we're bringing in, well, sorry, a new constant we're bringing in. It's lambda lots of MQ. Lambda is going to be a fraction. we don't really need to write this, but lambda is a fraction. So it's going to be something like a third or 2/5 or something like that. So lambda is going to be a fraction. Then we're also going to use the other diagonal. So a to c is equal to minus a plus c. And where is p along that line? Well, it's some fraction of the way along the line. It might be 0.4 along the line. It might be 0.45 along the line. So we'll say that a to p equals, and use another letter, could use the Greek letter mu. It's mu lots of AC. So it's this. And again, mu is going to be some fraction or a decimal, if you like. Is a fraction. It's going to be a number between 0 and 1. So we now have an idea where p is on our diagonals, if you like, our MQ and our AC. What we're going to do now is we're going to get to P using those two different routes, but starting from the same place. So in this question, it asks us to express OP. So let's use that bit. So OP equals, let's write down one down here. So OP equals, don't worry too much about what the questions are asking here actually, you kind of do it all at once. So O to P could be O to M plus M to P, in which case I'll say a half A plus what I've written above, which collects together, so I'm going to collect together the amount of A's here, so I've got a half plus lambda over 4, lots of A's, plus I've got lambda, lots of C's. Then I'm also going to work out, let's do it in a different colour, I've also got OP, but via A. So O to A plus A to P. So O to A would be A, plus A to P, which we've worked out above this, is, and if I collect together my A's here, I get 1 minus mu, and I collect together my C's, I get mu lots of C. Now these things here are both equal to OP, so should both be equal to each other. If two vectors expressions like that are equal to each other, it means you've got the same number of A's. In other words, a half plus lambda over 4 should equal 1 minus mu, and you've got the same number of C's, so lambda equals mu. So if I put that now into here, that'll give me a half plus lambda over 4 equals 1 minus lambda. And add lambda to both sides, I get 5 lambda over 4 equals a half, and that'll give me lambda equals 2/5. So what we found is that P is 2/5 of the way along M to Q, and since mu equals lambda, mu is also 2/5, so it's 2/5 of the way along A to C. Therefore, so let's just finish off. Therefore, MP, or let's say AP to PC, let's say that AP equals 2/5 of AC, therefore AP to PC is 2 to 3. So we can do one more of those. Oh, here's another one here. Let's have a go at this one. So we're trying to find the ratio ON to MB. We've got to add the point N in. So, oh yeah, here we go. So C is a point up here, because it's double O to A. Then M is a point in the middle here. And if we draw a line through C and M, we end up at N. So we're trying to work out where N is. So as before, we're going to say, well, N is on two lines. We're going to say what fraction of the way along each line is it. So we're going to say O to N basically is lambda lots of O to B. And we're going to say that C to N is mu lots of C to M. Now this is slightly different from the last one, because this time mu is not going to be a fraction between 0 and 1. It's going to be, well, it won't be a whole number, but it's going to be a number bigger than 1. So it's going to be something like 1.2, let's say. But this is trying to work out where n is by saying it's an extension of c to m and it's a fraction of the way along O to b. O to b is going to be b, so this is lambda lots of b, that bit's a bit nicer, and then we've got to work out c to m. So to get from c to m, I'm going to go c to a plus a to m. C to a is minus a, plus a to m, well that's half of a to b, so that's half of a to b, which is minus a plus b. So if I collect together my a's, I get minus mu minus a half, and for my b's I get a half mu lots of b. And over here I get lambda lots of b. And, oh, this one's just Cn. So now if we want to all start from On every time, so let's use, we've got On on the left, so let's say that On is O to C plus the Cn we've just worked out there. So that's going to be 2a plus the thing above. Collect together my a's, I'll get 3 over 2 minus mu plus a half mu lots of b. And this should equal this. So it means the number of a's should be the same and the number of b's should be the same. So I know that lambda should be a half mu, that's the b's being the same, and the a's should be the same, but that means 3 over 2 mu must equal 0. So that tells me that mu is equal to 3 over 2. And it tells me therefore that lambda equals 3 over 4. So apparently Cn is 3 over 2 lots of Cn, so it's 1.5 lots of that, so it's an extra 50% of the way along. And apparently n is 3/4 of the way from O to B. That looks about right. I would have perhaps expected it to be 4/3, but unless I've made an error, which I don't think I have there, those answers don't seem crazy. And there's one more of these on the sheet which you could have a go at below. Yes, it did seem a little bit bigger than I was expecting, but fortunately I've just checked and I can confirm there was an error, which is that this should have been minus a half mu. So that changes this expression here. So let's just edit that. Which now means it should be 2a, I should really write this out in full and then it'd be a bit easier. This is minus 3 over 2 mu lots of a plus a half mu lots of b, which gives me how many a's? 2 minus 3 over 2 mu plus a half mu b, which means that, let's just cross this out, make space for this. Now this should equal 0, which is going to give me an answer which looks a bit more realistic. 4 over 3, which looks a bit more like what I was expecting. N is 4 over 3 lots of Cm, and that means that lambda equals 2 over 3. So it's 2/3 of the way along, which looks about right. And it sort of shows the benefit of doing a diagram which looks reasonably accurate and just sort of, is it about right? And then that's helped me spot the error earlier on. I hope that's helpful. Those ones where you're finding where it is by introducing an extra parameter, I would say that's not a particularly common question, but being good at it is also enabling you to practice that idea of going via different routes anyway. But don't maybe spend a disproportionate amount of time on that.